What does it really mean for an AI to think? Today, we're diving deep into the prompt advantage nobody can see. The next strategic divide in AI is not about model intelligence or compute budget. Importantly, two people using the same Claude 3.5 Sonnet instance get different results. One unlocks reasoning breakthroughs while the other gets surface level summaries. The difference is invisible and untaught, but it's growing exponentially. This hidden advantage is becoming more significant every day. But here's where it gets interesting. Ceiling model performance is converging across the board. API costs are collapsing rapidly in the market. Local deployment is becoming the standard practice. Every organization now has access to frontier intelligence, but output quality varies 10 times between users. The bottleneck has shifted from model capability to human to AI communication effectively. Most professionals cannot see this constraint clearly. So what's the real problem? Let's talk about why prompts fail. AI models are often treated like search engines or chatbots. Next, users focus on outcomes instead of reasoning paths. Importantly, they ask for answers without setting evaluation criteria. More specifically, there's a lack of structured frameworks for constraints. Notably, the model follows instructions exactly as written. Thus, precision requires proper architecture, not just conversation. This raises a critical question: latent communication architecture. Every prompt activates a latent reasoning graph inside the model. Chain of thought tokens allocate compute towards specific inference paths. System prompts set boundary conditions across all exchanges. Few-shot examples calibrate output distribution, temperature, and top P control exploration versus exploitation. These parameters form an invisible API between human intent and model execution. Now, let's zoom in on the prompt advantage. Defined prompt advantage is the measurable difference in output quality from communication architecture, not model capability. It shows as structured reasoning depth and constraint adherence. It also includes edge case handling and lower hallucination rates. This advantage grows with every interaction. It doesn't need extra compute or fine-tuning access. Here's something most people overlook. 3 component layers. Metacognitive framing specifies thinking protocols before answers. Next, constraint engineering defines what outputs must avoid. Output shaping prescribes format, granularity, and confidence thresholds. Each layer operates independently. Importantly, combined, they transform stochastic generation into deterministic-like execution. Think about this for a second. The execution workflow phase 1 is to decompose the target outcome into reasoning subcomponents. Next, write system prompts that enforce reasoning patterns across turns. Importantly, structure user prompts with role, task, format, and constraints. More specifically, chain prompts iteratively feeding outputs back as context. Notably, evaluate against rubrics rather than intuition. Repeat to improve latent performance each cycle, and this is where things get complex. Measurable divergence code generation without prompt architecture has a 62% pass rate. With prompt architecture, the pass rate increases to 89%. Data analysis without structure shows surface correlations. With structure, it enables causal inference chains. Documentation without constraints produces generic summaries. With constraints, it delivers stakeholder-specific insights. Same model, same compute, different communication protocols. The gap is systematic, not sporadic. But here's where it gets interesting. The hidden inequality: schools are not teaching prompt literacy. Next, corporate training focuses on tool operation. Importantly, it does not focus on communication architecture. Most workers believe prompt engineering means writing clearer sentences. Notably, the highest paid professionals will not know more information. They will structure intent better than others. This creates a new class divide hidden inside every chat interface. So what's the real problem? Let's talk about cost of invisible incompetence teams. without prompt architecture spend 70% of iteration time on clarification and repair. Each poor prompt burns tokens, latency, and attention. Importantly, organizations misdiagnose output failures as model limitations. They switch providers instead of upgrading communication protocols. More specifically, the true cost is not compute, it is foregone reasoning capacity left dormant. This raises a critical question: the literacy mandate. Prompt architecture must become a core competency alongside code and data literacy. This requires rubric-based evaluation and structured prompt libraries. Deliberate practice with feedback loops is essential for mastery. Organizations that systematize communication will outperform peers. The window for building this capability is closing quickly. Now, let's zoom in on inevitable divergence. Every interaction with frontier models shapes your team's communication architecture. Poor prompts lead to poor outputs and ultimately poor decisions. Great prompts unlock latent reasoning that builds a strategic advantage. The prompt advantage remains hidden until it becomes obvious. At that point, the gap is permanent and hard to close.